Imagine this for a second. You're at a bustling gem fair, maybe somewhere like Geneva. The air's buzzing, lights are catching on, just incredible jewels everywhere. And there's this gem dealer, totally lost in thought, admiring this stunning emerald. Its screen is just deep, like it holds secrets. Then the theoretical physicist walks up, they start talking, looking at the emerald together, and the physicist smiles, leans in, and says something completely wild. They say, the atoms in that emerald, some of them weren't made here on Earth. They came from dying stars, smashed together in space billions of years ago. That idea, that kind of startling truth, which comes from research like the sources you send us, that's what we're diving into. Welcome to the Deep Dive. This is where we take your sources, your research, your insights, and we boil them down to what really matters, getting you up to speed fast. And today we're on this amazing quest, part cosmic, part geological. We're tracing the story of beryllium. This is one of the rarest elements here on Earth. And we're following its journey, like from the absolute vastness of space right into the heart of every single emerald.
So, okay, let's unpack this. How can a gemstone, something from deep in the earth, carry a message from the universe? It just blows me away.
It really is one of the most remarkable stories connecting, astrophysics and geology. To really get it, we kind of have to start at the beginning, how elements are made in the first place. The universe has a few main ways, a few, let's say, element factories. First off, right after the Big Bang, in the first few minutes, things were incredibly hot and dense. That's when the lightest elements formed, mostly hydrogen and helium, maybe a tiny bit of lithium. That's called Big Bang nucleosynthesis, or BBN. That set the initial cosmic recipe, basically.
Okay, so the Big Bang gives us the absolute lightest stuff. Hydrogen, helium, what about the rest? Did stars handle that?
Exactly. As the universe cooled down, gravity pulled that hydrogen and helium together. Stars were born. And inside stars, especially the big ones, it's like a furnace. Immense heat, immense pressure. Through stellar nucleosynthesis, lighter elements fuse together to make heavier ones. Carbon, oxygen, all the way up to iron.
Okay. So stars are the main factories for a lot of the elements we know.
For a lot of them, yes. And when the really massive stars die, they explode as supernovae. That explosion scatters all those elements they created, literally stardust, out into space, which enriches the next generation of stars and planets. And for the really heavy stuff, heavier than iron, like gold or uranium, we now think things like neutron star mergers are key. These incredibly violent events create them.
Right, so Big Bang, stars, supernovae, neutron star mergers. That sounds like it covers almost everything on the periodic table.
Yeah.
But you mentioned beryllium is different, along with lithium and boron, right? Libab, you call them. What makes them the exceptions? Where's the twist in their story?
Well, this is where it gets really interesting. Lithium, beryllium, and boron libab, they're kind of the oddballs. Unlike almost everything else, they are not typically made during the normal fusion processes inside stars. Actually, stars are so hot, they tend to destroy these elements. They're quite fragile, atomically speaking.
Wait, destroy. So stars are like incinerators for beryllium?
Yeah. In a way, yes. They burn it up rather than create it. And the Big Bang wasn't much help either. BBN was, the papers say, hopelessly ineffective at making the stable isotopes like beryllium-9 or boron-10 in any significant amount. That's why if you look at a chart of how common elements are in the universe, there's this big dip, this kind of gap between helium and carbon. And right at the bottom of that valley, super scarce, you find lithium, beryllium, and boron. They just don't fit the main production line.
That's completely counterintuitive. Stars make elements, except these ones they break. So if the Big Bang didn't make beryllium and stars destroy it, where on Earth, or rather, where in the universe does it come from?
This leads us to its real and quite fascinating origin, a process called cosmic ray spallation. And notice, this isn't happening in stars. It happens out in the vast, almost empty space between stars, in the interstellar medium.
Okay, cosmic rays, those are the super fast particles zipping through space, right? Mostly protons.
Exactly. High-energy protons moving at near light speed. And the space between stars isn't totally empty. It's got gas and dust, including heavier atoms like carbon, nitrogen, oxygen, stuff that was made in stars and blown out by supernovae earlier.
So these fast protons hit those heavier atoms out in space.
Precisely. And it's not a gentle tap. It's an incredibly high-energy collision. This impact literally shatters the larger nucleus, the carbon or oxygen atom. It breaks it apart. That's spallation. Think of it like a cosmic demolition derby at the atomic scale.
Wow. Smashing atoms apart in deep space.
Yeah. And the fragments, the pieces left over from that shattering, some of those fragments are beryllium nuclei, specifically beryllium-9, the stable kind. Also things like helium-3, lithium isotopes, boron isotopes. They're the debris from these interstellar collisions.
So that's why beryllium is so incredibly rare here on Earth. It wasn't made efficiently by the Big Bang or in stars like, say, carbon or iron. It needed this very specific kind of violent secondary process out in the void, smashing things apart, not putting them together.
Absolutely. Its rarity is a direct fingerprint of this strange origin story. It's a cosmic outlier. And, this understanding actually overturns some older ideas. For a long time, scientists looked at meteorites which contained decay products of radioactive beryllium-10. This showed beryllium-10 was around in the early solar system maybe 4.5 billion years ago. The assumption was, well, it must have come from a nearby supernova explosion, maybe the one that even triggered our solar system's formation.
Ah, that makes sense. A big explosion nearby seeds the cloud with fresh radioactive stuff.
It seemed logical, but recent nuclear physics work has really shaken that up. They recalculated the reaction rates inside supernovae using much better data rates, up to 33 times faster than previously thought. And with these new, faster rates, it turns out supernovae are actually really good at destroying beryllium-10, not making it.
Whoa. So the explosion that was thought to create it actually wipes it out.
Pretty much. It gets consumed in the inferno. So supernovae are unlikely to be the main source. This makes cosmic ray spallation, those collisions in interstellar space, almost certain, as the researchers put it, to be the primary source for the beryllium, including that early solar system beryllium-10.
So the beryllium that ended up in our planet, in the rocks, it likely came from these interstellar smash-ups traveling across space for who knows how long before the sun and planets even formed.
That's the picture, yes. It's a survivor, forged in cosmic violence, traveled unimaginable distances, and eventually got swept up into the cloud that formed our solar system. It really makes you think about the history embedded in matter itself.
Okay, my mind is officially blown by the cosmic journey. But connect it back for me. How does this incredibly rare, cosmically smashed element end up in one of Earth's most cherished gemstones, the emerald? What's the link there?
The link is absolutely fundamental. It's the definition of the gem. Emeralds aren't just any green crystal. They are a specific variety of a mineral called beryl. And the chemical formula for beryl tells the whole story. It's bello, euro, euro.
B, beryllium. 3 atoms of beryllium in every basic unit of beryl.
Exactly. Without that beryllium, that B, right at the start of the formula, you simply cannot form the beryl crystal structure. No beryllium means no beryl. And since emerald is green beryl, no beryllium means no emeralds, period.
So every single emerald, that beautiful green color, owes its very existence to beryllium atoms forged billions of years ago by cosmic rays smashing into other atoms between the stars.
That's the core connection. It's literally built from this cosmic traveler. And what's also fascinating, if we zoom back into the emerald itself, is what else it holds. Emeralds often contain inclusions, tiny trapped bits of other minerals, little pockets of fluid, maybe even gas bubbles. These got stuck inside the crystal as it grew deep within the Earth's crust millions of years ago.
Oh, right. Gemologists use those inclusions sometimes to tell where an emerald came from or if it's natural, like little time capsules.
Exactly. Geological time capsules. They tell us about the specific conditions deep inside our planet when that emerald formed, the pressure, the temperature, the surrounding chemistry. It's a snapshot of Earth's deep history.
Okay, so let me get this straight. Inside an emerald, you have these inclusions, telling a story about Earth's geology, millions of years old. But the actual atoms holding those inclusions, the beryllium making the crystal structure itself, those tell a story that's billions of years old, stretching back to interstellar space and cosmic collisions.
You got it perfectly. That's the profound duality, this incredible fusion you hold in an emerald. The inclusions speak of Earth's depths and its geological past. But the essential beryllium atoms trace their lineage back to the galactic nursery, to events that happened long before Earth even existed. It's a genuine meeting point of the terrestrial and the cosmic. Deep Earth processes providing the conditions, but using building blocks forged in deep space.
It's like holding stardust that's been shaped by the Earth. That's
Yeah.
really something.
It truly is. It shows how interconnected everything is. The elements forged in stars and space eventually make their way to planets like ours and get incorporated into everything from rocks to life to beautiful gemstones.
So what does this mean for us? For you, listening? Well, the next time you see an emerald, maybe in a museum, a shop, or even in a piece of jewelry, just pause for a second. Know that you're not just looking at a pretty green stone. You're looking at a tangible piece of cosmic history. A gem holding secrets that span billions of years and light years of distance. It's a testament to this wild universe, turning cosmic debris into breathtaking beauty. Makes you wonder, What other everyday things hold such deep stories?
Absolutely. Each emerald is not just a gemstone, it's a message from the universe, written in green fire, carried from ancient cosmic events and interstellar collisions right here to Earth, maybe even to your hands. It's a stunning reminder that we are, quite literally, made of stardust.
Thank you for listening to this deep dive. Don't forget to subscribe or like and follow our company GemMatrix online for more stories like this one.